Welcome to the damped glider video. In exercise 1, we'll be using Hooke's law, a force sensor, and a position sensor to determine the spring constant.
Hang the force sensor from a stand and attach it to the analog port on your data acquisition interface.
Hang a known mass from the sensor.
Open Data Studio and select Create Experiment. Click the first analog jack and select Force Sensor. Set the sample rate to 250 Hz and the sensitivity to medium. Click Calibrate Sensors, and in the 0.1 section, enter the force in newtons that your known mass is exerting on the sensor. Click Read from Sensor.
Replace the mass hanging from the sensor with a second known mass.
In the 0.2 section, enter the force this mass exerts on the sensor, and click Read from Sensor and OK.
Set up a stand at one end of the track. Arrange the force sensor and motion sensor as shown. Plug the motion sensor into the data acquisition interface with the yellow plug in port 1.
In Data Studio, click Setup, click the first digital port, and select Motion Sensor. Change the sample rate to 25 Hz. Create a graph of force versus position. Tape a flag to the glider and attach it to the force sensor with a spring. Press Tear on the force sensor, press Start in Data Studio, pull the glider back, and press Stop.
In exercise 2, we'll be finding damping coefficients of underdamped systems at various air pressures and glider lengths.
Select 3 gliders of different lengths and record their masses.
Add masses to the gliders so that they're approximately equal. Note that the masses should be added to the top, not the side.
Turn on the blower. Set a glider on the track. If it moves, level the air track by rotating the feet at the appropriate end.
Attach a flag to the end of the glider to make it visible to the motion sensor.
Attach a spring from one end of the glider to the base of the air track or a stand. Attach a second spring from the other end of the glider to a stand and stretch the spring so a little tension is present. Arrange the motion sensor so that it's at least 15 centimeters from the flag and there's nothing in between. You may have to experiment a little in Data Studio to make sure it's working properly. Plug the motion sensor into the interface with the yellow cable in port 1.
Adjust the air pressure to achieve underdamped oscillation. In Data Studio, create a position versus time graph and press Start. Set the system in motion. Try to get a minimum of 5 oscillations before the system damps out.
Display position and velocity traces versus the same time axis. Show the same run on each graph, and you can view the phase difference phi. Repeat this exercise for the other 2 gliders at the same air pressure setting, and then try a different air pressure setting.
In exercise 3, we'll be comparing critically damped and overdamped oscillatory systems.
Adjust the air pressure to achieve critical damping. Once you're as close as possible, record the motion using Data Studio.
Adjust the air pressure again, this time such that the system is overdamped. Again, record the motion using Data Studio.
This video was created entirely with recycled photons.